what are we going to talk about? I want to demystify some of the concepts that we are constantly seeing in the internet. Like, how many of you have heard about microservices or have read something about microservices in the internet? Yeah, it's like a very popular topic right now. So my idea is I want to demystify it. I want to explain you all the, what is behind all this hype. And I want to show you how we want to apply this to Liferay, okay? So, the monolith. And we have talked about modularity for a long, long time, for the last 2, 3, 4 years. We have been talking about modularity and the way we develop applications. And the way we develop applications is that way. And it has been done on that way for many, many, many years. And it is, we have a regular database, like MySQL, Postgres, whatever. We have an app server, and I'm focusing only in the Java world, okay? But I guess for the Ruby guys, for other platform guys, it's exactly the same. Is I have a database, and I have an app server or whatever, where I put all my logic, I put all the UI, I put all the services, all my model, all my domain, and when I move into production, I maybe put some load balancer in front of my clients, just communicate to it, okay? It's fine. I mean, it's really easy to develop these kind of applications. You have everything all together in a very nice place, and you have everything, like, everything is okay, because you have everything here, and it's fine. It's very simple to deploy. You just need to create your WAR file, your ER file if you are using something like WebSphere or whatever, and just deploy it. And it's very easy to scale, because you just need to create a new element in a cluster and just put behind a load balancer. It's fine. I mean, I think, or I guess any of you know how to configure a load balancer, so it's pretty easy. And it works really well for really small applications. Sorry. But what happens when you move to a bigger application? Liferay is about 5 million lines of code. Okay? When you have 5 million lines of code in a single place, it's really hard to understand everything. It's really hard to maintain. It's really hard to reason about. When you hire a new guy and you bring him into the team, it's really hard to train him and to explain him, okay, you need to change that, and you have to make sure that making this change is not breaking anything at the other side of the product. So this is hard when you have a really big application. It makes really, really hard to follow a continuous deployment approach. If I want constantly deploy new features into my product and to do it continuously, it's really hard because I constantly need to deploy everything. So I need to make like a small change, like 2 lines of code, and just fix a bug, and I want to deploy. I have to deploy, in this case, the whole Liferay. So it doesn't make sense in many scenarios. And it's really, really hard to try or to adopt new technologies. I remember like 2 years ago, I tried to make like a small piece of code for Liferay, for Liferay code in Scala, and I couldn't. Because just bringing the Scala compiler into the build, it was really hard. I mean, at the end I was able to do that, but it was really, really hard. So having everything in a single place is like really hard to try or to adopt new technologies or even architectures. Some more problems. Scaling sometimes is really difficult. I mean, it's really easy because you just put a new element behind a load balancer and it's okay, but this is the only way you have to do that. You don't have any more options. And it's really hard to focus people. It's really hard to focus teams because everything is interconnected, everything is related. It's very hard to say to the guys who are in charge of the forums, or the message boards, sorry, to say, okay, guys, this is your work, but anything you do here is not going to break anything in the other side of the portal. And this is really hard when you have everything in a single place. So I would like to talk about the scale cube. I'm going to make this question. I think I know the answer. Anyone here has read The Art of Scalability book? No. 3 of 3. Okay. So this is a really nice book. about the scaling systems, and it proposed this, not architecture, but this talks about 3 different ways of scaling system. It's the 3 axes in the cube. I will talk about the 3 different axes, okay? The x-axis scaling is what we have seen before, is you have multiple copies of your applications just behind a load balancer, and it's very easy to do because we are very used to doing it on that way. And it's a common approach to do scaling. Just, I have my application, Liferay or whatever, just a bunch of copies behind a load balancer, whatever, the load balancer you want, and all my clients communicate through the load balancer. It's perfectly fine. The other approach is called the C-axis scaling. Sorry. So, using this approach, every server in the cluster keeps the same code. I mean, exactly the same. I have to redeploy everything on all the different servers. The difference is that every server is only in charge of a small subset of the data. What does it mean? That we need a smarter routing. So let's suppose that I want to follow this approach, and sorry, and I have a different bunch of clients, and I want a bunch of clients who has an SLA of 2 nines, and a bunch of clients that they don't have the 2 nines SLA. So what I can do with this is the clients with the 99.99 SLA, I can deploy a different cluster, so I can fulfill the requirements on a different way than the other clients. So I am scaling in a different way. So, which are the benefits of this approach? Like every server or every cluster deals with a small subset of the data. We improve data caching, we improve I/O traffic, we improve transactions, we improve all isolations, because what happens if the cluster on the right gets broken by any reasons? It's fine, because the other guys are not being affected. Which are the drawbacks? That at the end, we need a smarter routing, and we increase some of the operational complexity. But what happened with applications is still the same. We have the whole application, we have to develop in a single place, and all the developers need to know about everything. So we haven't solved this problem. So the Y scaling is everything about, is about microservices. And all the microservices is this axis scaling, okay? When you do microservices, what you want to do is do a functional decomposition. It is like, I need to break all this stuff in small services to communicate each other, but there is no golden rule. There is no, okay, you need to split on that way or on that way, and many people follow many different approaches. You can do birth-based decomposition, you can do entity or resources decomposition, you can do it on the way you want. There is no golden rule. And you end up with something like this. Like you have a different pieces, and they talk each other in many different ways. So, sorry. Which are the benefits of that? Like we have small pieces, they are reasonably small. We have a faster startup because they are small and they are supposed to be able to start up by their own. You can scale up every piece independently. So if my system needs to, if I go back, I need to I need to scale the billing system. I can scale the billing system on their own, and I don't need to scale all the other stuff in my system. We improve the fault isolation. If here, for any reason, the holiday service is broken, for any reason, it's fine. But I'm not bringing down the whole application. I'm just bringing down the holiday service. And one of the nice things is that we break with the long-term tech commitment. What does it mean? Like if we have small pieces, easier to change something. It's easier to, I don't know, to rewrite it, and I have my user's UI, maybe I want to move from the GSP, from everything in JavaScript, or I have the holiday service written in Java, and I want to write it in Clojure, or whatever. So, yeah, if you see the previous slides, everything is like, okay, this is amazing, this is awesome, but there is no free lunch, guys. And when you move into this approach, there are a lot of drawbacks, but nobody talks about them, and I want to show you some of them. And is when you move into this approach, you have like many different pieces in place, and they are like moving parts because you are moving into a distributed system world, and distributed systems are hard, but they are really, really, really hard. And if some guy tells you that it's not true, he's wrong. Distributed systems are really, really hard. So we split our application into many different pieces, and we communicate each other. We put in completely separated machines, so we are introducing complexity in our applications. And we introduce problems like, we will go through them, inter-process communications, moving parts, operational stuff. So let's talk about client service. So when we have everything in a single place, our clients just talk to our server, which is fine. What happens now? Maybe we have a split in many different services, and we have a bunch of clients, but the granularity of the services doesn't fit the client's requirements because they are so low level that we need to build a kind of gateway. What does it mean? It means like the API for the services to consume from the clients is not enough, so we need to build something on top of it, just to allow the clients and the server to evolve by their own. So this is something new. And we need to communicate in the other way, just in the server side in this case, we need to communicate every single piece. So we introduce the inter-service communications. So I have the client service, I have the billing system service, I have the holiday service, all the business you need, and you need to communicate each other. And ideally, they will be deployed in different machines. So how to do that? One approach is using synchronous RPC, which is fine. I mean, I think all of you maybe know something like REST, SOAP, or they are trying to be simpler. We can discuss about that. And the problem is that you need to put something in place which is called a discovery service. Let's suppose that I have, go back to here. Let's suppose that the holiday service, the billing system need to ask the user management, okay? And I have deployed like a cluster of user management, like 3 nodes. How the billing systems knows how to contact the user management if I have deployed 3 elements, 3 nodes? We need a discovery service. We need a piece in our infrastructure who is in charge of making sure that all the services are available, how they are behaving, are they alive, are they behaving right? So we have to put in place something like, I guess many people have heard about Zookeeper, maybe etcd, Consul, whatever. But DNS discovery, but this is something you need to put in place, this is something you need to configure, this is something you need to monitor, so it's not simpler. The other approach is using some kind of asynchronous messaging, and this is the right way to do distributed system, by the way. So basically, we are decoupling. What we are doing is like, I'm sending just a message asynchronously, and I'm forgetting about that. Just put a message somewhere, the client or the other service will get it somewhere in the future, and I'm just forgetting about that. Eventually, in the future, I will get a response. It's fine. Again, if you use something like AMQP or EMS or whatever, is something you need to put in production. It's something you need to monitor, you need to manage, you need to scale. So again, it's not simpler. Let's move into different stuff. Let's move into data management. Potentially, each service could have their own database. Like I have split everything, like the billing system and the user systems. Potentially, they could connect to very different databases. Even not only different databases in the sense like I'm connecting to MySQL, I'm connecting to Oracle, but I'm connecting to MySQL and the other service is connecting to some NoSQL storage, like React or Cassandra. It's really, really hard. How do you do transactionality? How do you deal with that? Many people don't do that. They just don't have transactions. It's fine. But you have to do the trade-off. Or maybe it's even harder. Maybe you can move to a completely different approach. You can move to even driving asynchronous updates, which means a completely different consistency model, which is fine. But again, you have to do the trade-off. So it's a very quick tour through some of the different scaling approaches you have to scale your applications. And I want to show you something. This is my personal vision on microservices, which is based on OSGi. And I want to sit in the middle. I want to see that we have like the monolithic, and we have like the other approach, which is like far, far away from this. And I want to sit in the middle. Every time you need it, you can move to the right. Okay, but only if you need it, because I think it's simpler. So I don't have too much to say about OSGi. We have talked it many, many, many times. It's just kind of module system for the Java world, for the JVM world, actually. And the nice part of OSGi are the services. Actually, OSGi has microservices called microservices before all this hype. The part of the ice, this is the upper layer, okay, the services. The bundles part and the modules part is something which OSGi has, but this is something that the Java language should do. So OSGi is trying to solve this problem, but again, I think the nice or the most powerful feature in OSGi is the services, is not the isolation. So, which are OSGi services? They are just Java classes, they are regular components, which are running in the same JVM, and they are highly dynamic. So at any point in time, an OSGi service can appear or disappear, even if you are running within the same JVM. When you get an OSGi container, you get this for free. The service registry is implemented on the core piece of OSGi. And you get a new or your own lifecycle management, so you don't depend on an application server or whatever. So we are able to split all all our application in different pieces, and we have to communicate each other through using services. And actually, we can deploy it independently. So let's suppose that is some of the work we are doing right now. We are getting modules out of the core, and we are getting like the polls, bookmarks, Amazon rankings, whatever. And we are moving it out of the core, and we get like independent deployment. What does it mean? That I can deploy the polls independently of the whole portal, or the bookmarks, or the message boards, and they communicate each other using services. So these services can appear and disappear at any point in time. And this is very related to distribution. We will talk about that in the future, later on. But we get some nice features, but we are missing many, many other things. Like, we get independent deployment, but we are still living in the same JVM, which happens if I deploy a new service which consumes the whole CPU. We are done. I've completely broken my application. Even if it's a service, a completely isolated and independent service, and I'm deploying within the same JVM, I don't. There has been some research lately by the IBM guys in the multi-tenancy on the JVM, but it's nothing really, really useful. So, I mean, it's really nice, it's nice research, but it's not the solution for this problem. We have partially solved this problem. So we have break everything into small pieces, and we are able to communicate each other. But we are still running within the JVM. So we are still very tied to the JVM programming languages, which is fine. At least if you want to do something, in this case in Liferay, you have to do it in Java. If we are split our applications into small modules, we are able to do, like, for example, we will be able to rewrite bookmarks in Scala. I don't know why, or even in Clojure, or Groovy, wherever. But what happens if I want to rewrite it in Go, or in Erlang, or I can't, because I am still running within the JVM world. So we are missing this still. We are missing the real isolation, we are missing the independent scaling, and there are many different solutions to these problems. We can spawn new processes, new JVMs, but again, this is a distributed system problem. So because of I'm spawning a new process, I need to communicate each other. So all the hype with Docker could help us, but you have to deal with that, and nobody is going to deal with it for you. Sorry. So how do you solve this problem? You have the common approach, and I deploy in a different machine, and a different process, and a different VM in Amazon, whatever you want, and I communicate all these services using REST, using ShareMQ, using MUKP, whatever technology you think is right for your solution. And it's perfectly fine. And I want to propose you a different approach. And it's using the OSGi remote specification. This is something which is a standard, and is implemented in the OSGi Alliance, and it's an extension to the service model, okay, to the service registry. And it is kind of, I have a service, an OSGi component, and I say, the only thing I have to say is, I want this to be distributed. I want this to be able to be consumed from any other machine, from any other registry in a different container. It's a nice way to do that because it's very simple. It's really, really simple. Your API, you don't need to put anything in your code. Just a bunch of properties I will show you. And you are not tied to any technology. What I mean is that you can use to communicate each other, you can use HTTP, you can use EMS, you can use whatever you want. It's just an implementation detail. So there are two different specs which are dealing with that, which is the remote services. It's basically how all the services communicate each other, and the remote service admin, which basically says how you deploy all this stuff. Like, where are all the services located, how are they doing, all the topology. So this is the OSGi remote services. And this is the way it's implemented. Sorry. This is the way it's implemented. It's really, really easy. There is just a topology manager which looks for all the services and how they are deployed. And the remote communication which says, okay, when I look for a service, I say, okay, you are there, I'm sending you a request, I'm invoking you, and under the hood, how is this call done? Through an RPC call, through a message passing, whatever. But this implementation takes care of it. Of course, it doesn't solve all the problems, because you are moving into a distributed system world. You still have to deal with many of the different problems we have talked before. So let's suppose, for example, this is something we have talked about many times within Liferay, and let's suppose I have Liferay, and they are already modules, not the message boards, but all the other ones, and I have a single instance of Liferay, okay? For any reasons, the message board service, I want to scale it independently. I want to, because I have like thousands of clients concurrently adding or reading messages or adding messages or whatever, I need to scale it. So I need to, I want to do like, okay, I will try to get the message boards, deploy it in a completely different set of machines, and scale it, like build a cluster of just message boards. And how the clients deal with that? Ideally, they don't have to do nothing, ideally. But what I mean is, like the clients, when they ask for a message board service, the registry, the OSGi registry with all these specs, I'm just consuming the message board service. For me, they will give me a reference to this service, but I don't know where this reference is. It could be in the main Liferay installation, but it could be in any of the other machines. But I don't know anything about that. So I can scale independent parts of the portal. And how to do that? It's fairly easy. It's no API. There is no custom API in your code. You just need to say, OK, from this service, in this case, this is from the Pulse module, from this service, I just need to say, OK, export all my interfaces in a remote way. So I have the portal running. I have to deploy a bunch of modules which make all this magic happen. Like, I have to deploy these modules. Actually, there are 3 different options. There are like the Amdatu guys from Luminis, and the Eclipse communication framework, and one more, I can't remember the names right now. So you just need to deploy their bundles, and this is something you get for free. I mean, even if Liferay doesn't choose to do that, you can do that. If you follow the new programming paradigm we are trying to adopt in the 7.0 release, you can do it by yourself. We don't have to do nothing. That's what I mean. It's something you can do it in 6.2. If you use the OSGi approach, you can scale your service on that way. It's up to you. It has nothing to do with Liferay. It's something we get for free from the OSGi Alliance. You don't have to do anything. Of course, you need to deploy and configure all this discovery service and all this implementation. But in case of the Amdatu guys, which is the reference implementation of the specs, they are just 3 bundles. They are 3 YAR files. So, and this is the only thing you need to do. Yes, OK, my module is available to export these interfaces remotely. And you can say, I haven't put it here, but you can say even I export all my interfaces, but I only export all my interfaces only through HTTP, or only through using SOAP, or you can choose that, and only using properties. So, how does it apply to Liferay? So we are trying to, as you already know, we are trying to use OSGi as the core technology of the product. So we are pushing hard or moving hard into that direction. And we are trying to split the product into really small pieces, like getting many of the core applications like bookmarks, like message boards, like wiki, all these, what I call big applications. Hopefully someday we'll be able to do the same with documents and media or something like this. And we are trying to break it down, and we are trying to get isolated pieces which communicate each other using a well-done and well-defined API, so they can evolve independently. And we are still with the problem that we have. We are running in the same JVM, which is fine for now. We have already done some work with the port and sandboxing, but it's a different approach. But our goal is that we want to allow you to scale your systems independently, and we want to focus efforts. We want people to build their applications, and they just can focus on build their applications, and they don't need to break the whole portal because they are making some change within the message boards. And I think I'm run out of time. So, do we have time for questions, or?
I think we'll have time for one question, maybe, if anyone has one. No one?
A very short one. You said that it's possible to deploy such services with 6.2 version. Is there anywhere published the reference configuration or the descriptors you need to use to make it available?
Yeah, it depends on your choice. I mean, if you choose to deploy the reference implementation.
I mean the example project or something like this with one microservice which I could use for my project, for example.
Yeah, right now if you want to do the OSGi way, you have to use like or Eclipse Communication Framework or the Amdatu project with basically give it to you. You need to deploy a bunch of bundles, and of course you have to deploy, I mean, you need to develop your application in the OSGi way. I mean, you need to use services, OSGi services, and you get for free. But I mean, you need to go to these projects. There are just 3 bundles. You deploy them in your system and configure it. It's nothing more than that.
Okay. Where is it? Is it somewhere accessible, or do I have to study this myself, or do you have any article on this, or?
No, I have. If you want, I can show you a bunch of examples I have in my machine. But
perfect. Thank you.
Okay, we'll have to leave it there. Thank you, Miguel.
Thank you very much.